Take a look at this execution timeline. In an IBM Offline Coding Exam, a brute force approach hits the red zone almost immediately. To pass, your code must maintain a flat trajectory below the time limit threshold. Staying below that threshold requires linear efficiency. We achieve this by mastering the two-pointer pattern, a specific method for processing data in a single pass without redundant loops. Python is our choice here for its readability under stress, but the logic remains the same. You must track your time and space complexity with every line you write to ensure you meet the examiner's requirements. IBM graders look for mathematical proof of efficiency. Reaching the correct output is secondary to demonstrating that you can identify the most direct path through the data while the clock is ticking. LeetCode problem 1750 illustrates this perfectly. The objective is to analyze a string and remove matching prefixes and suffixes until no more deletions are possible. We begin by setting our two pointers at the absolute outer boundaries, index 0 and the final index of the string. If you move these pointers one character at a time, you risk exceeding your time limit. Instead, identify and clear entire contiguous blocks of characters simultaneously to maintain a linear pace. You must account for the case where the remaining string is made of identical characters. Your logic must ensure the pointers are strictly prevented from crossing, or you'll erroneously delete the same index twice. Look at the final positions of the pointers. Pause for a second and deduce the exact math needed to calculate the length of the remaining string without using an additional counter. The formula is simple: right minus left plus 1. This allows us to find the result in O of n time while using constant space. Successful string deletion isn't a search, it is an inward collapse of defined boundaries toward the center of the data. Now consider structure beta in LeetCode problem 2570. Here, we must merge two 2D arrays based on matching IDs. It is inefficient to dump this data into a HashMap and resort it. These arrays are already provided in ascending order, and your solution should exploit that fact rather than ignore it. We deploy two parallel pointers, I and j, to read both arrays simultaneously from the beginning. When the IDs match, we sum the values, append the result, and advance both pointers to the next row. If the IDs are different, we identify the smaller ID and move only its respective pointer forward after appending its value. The other pointer remains stationary until its ID becomes the smallest available. This synchronized traversal guarantees that we finish the merge in a single linear pass, resulting in O of n plus m complexity. Merging arrays is a synchronization task. Using the existing order of the data is always more effective than building a new sorting logic from scratch. You now have the two primary ways to apply this technique: inward pointing arrows for collapsing single datasets, and parallel arrows for merging multiple sorted sets. During the exam, write them out. Explicitly state your time and space complexity in your code comments. IBM graders look for this specific evidence that you understand the efficiency of your code. The source code for both problems is available in the description for your practice. Like and subscribe to keep sharpening your algorithmic skills. Coding exams test your ability to recognize patterns under fire. Mastering these optimized structures